Hey YouTube, CyberCDH here. Hope you're doing really good. Today we're going to take a look at this malicious Excel file. This Excel file's got some XL4 macros built in. I'm going to take a look at how to rip those apart. These are pretty sneaky, pretty challenging to analyze, but I'm going to show you some of the techniques that I use and some of the quick ways that you can get the key indicators of compromise from malicious samples like this. So let's dive right in to our virtual machine here. So we've got what I always do, any kind of sample is I want to run it first, just get a flavor for what's actually going to happen from a network perspective. So I've got my network traffic proxy through Burp Suite. Let's get Procmon on the go, just with a quick filter here for process creation. So let's get that up and running. Also, let's go back to my Excel file. You can see here I need to enable macros, but as I said, these are XL4 macros. These are not VBA macros, which you will see here in the interpreter. These macros were from a time before VBA was ever invented, and in fact, the macro code exists on this particular macro worksheet, but we'll get to that in just a second. First off, let's enable macros. Let's just see what on earth is going to happen here. Excel starts to think about things. That's fine. I get this pop-up message saying something's corrupt. I get calc.exe fire. That's a bit weird. And if I go to Burp Suite, you can see I've got at least one get request here to this care.academy/php and a response as well of 404 not found. That's a bit weird, right? So because we've got a get request to 404, but we've got this calc.exe that's fired. So calc's a bit weird. Why am I getting calc? A little bit of a spoiler here. So this particular piece of malware hits multiple C2s. In this particular instance, and the bad guys will play around with you. They will 302 redirect you to stuff which looks benign or stuff which is, not the true intended behavior of the malware if you hit the C2s often enough, i.e. if they think the malware is being analyzed. So this is one of those tricks. However, we'll get to wonder, how is it pulling calc down? Where's it getting that from? Is this the only network indicator that we've seen? Also, let's go back to our process monitor. What did we capture? Well, first thing to let's go into our tree view. A little bit easier to do Control and T and have a look and see what Excel spawned. Well, here we go. Excel launched reg.exe. If I maximize this a little bit and we open up this column, we can see here that it exported the contents of this particular Excel security registry key and saved it to the C users public folder into a reg file, and then it executed run dll32.exe. So it tried to run something, this .html, also from the C users public folder. So if I go to C users public, I don't see any of those files, but I do see this weird. Oh, I do see this this HTML file. Let's edit that and see what this bad boy is all about. I don't want to edit it there. That looks like to be an executable, which is all good. I think I saw some headings. So let me open with. Let me see. Let me browse. Let me go to HXD. Let's open this bad boy in HXD. Okay. And we can see here we've got 45A, the usual kind of headers of a portable executable. So that's a bit weird. We've also got this .dat file as well. So if we open the .dat, let's just open it in Notepad to see what is going on here. Notepad. We've got some weird and wonderful strings in here as well. So some weird stuff this malware is doing. Our job today is to work out how on earth it's doing it. So let's get rid of Burp Suite. We don't need that anymore. Let's go back to our sample. I'm going to open it, so close it and reopen it from my downloads folder. Let's come back into here and let's step through the malware. So we'll step through the macros. So first thing I'm going to do, just turn my Excel options around a little bit so I'm not using R1, C1 references and I actually get A, B, C, D at the top here. And then what I said before was that this uses macro XL4 macros, right? And let me just demonstrate a little bit about what I mean by that. So first off, you don't use the VBA interpreter. Use insert XL4 macro. It gives you this macro worksheet. And then what I can do is do stuff like set.value. This is a real basic function here. So set the value of cell B1 to be 123, for example, and then give it a return statement as well. There we go. And so if I right click and run on that, hit run, you can see that that code is executed and it runs top down, left to right. Something else to note is that if you have something in between your instructions that is just a load of nonsense, then lo and behold, Excel, the interpreter, will just skip over that and run it. So if I do that again, I don't get any errors. It just kind of skips over any noise. That is going to become very useful and apparent to us in just a second. So here, if we go to the auto open, which is a defined name where the bad guys have defined the entry point here. So when you enable macros, this is where the code is going to fire from. This is where the code is going to execute from. So this line 203 downwards. It's going to go top down, left to right. So it's going to work its way downwards from here. Ignore the white space, although bear in mind that the white space may be there for a reason. Maybe there to kind of put you off your analysis and just to make things a little bit more difficult to read. But also there might be reason why there is particular large chunks of white space in particular. So we can see here there's quite a large chunk. First thing to do, we know where the entry point is now, and we'll come back to that in just a second. What we want to do is just have a bit of an eyeball of the code. We can see that the code kind of all makes its way all the way down here in column E. If we keep on scrolling throughout this worksheet, we can see here further down in column I, we've got a load of weird and wonderful encrypted stuff, very similar to what we saw in that DAP file, for example. If I keep scrolling again, keep scrolling and scrolling and scrolling, eventually we come to another set of encrypted or encoded content here, which looks a bit weird. Again, keep scrolling and scrolling and scrolling. Let's see what else we get. We just want to eyeball the code right now. We get a list of integers. That's very interesting. And also keep scrolling. We get another list of integers. So a little bit weird, but everything seems to be, or the main body of the code seems to be in column E. I'm going to copy that out. It's easier for me personally not to use an Excel file to play around with this. I'll get it into a text editor, get it into Sublime here. You can see I've still got all of this white space though. So let's try and get rid of some of this white space. So I'm going to do where there's a new line or there's a tab, for example. We're going to get rid of that in the current file and just replace it with blank. Hit yes. Here we go. So now I've got it nice and clean where I can read it. However, we can still refer back to where it exists in this particular, in the cell references within our macro sample here. So let me go back to the entry point. Where did it start? Auto open. So it's this line here, this app.maximize. Well, what does that even mean? Well, so it's this line here. So I can move around now. So ignore everything above it. We're going to start line 62 and work our way down here. So as I said to you, the Excel interpreter will just will skip over any noise. This stuff in the middle, like this value here, if you control an F, it doesn't exist anywhere. It's not a function call. It's not an Excel4 function or anything. It's just a bit of noise. So we need to get rid of stuff like that, like these here. Just blank these out for now. And there's quite a few of them within this particular piece of code. But if I just quickly zip through these, there we go. So we've nice and easily kind of cleaned that up. So let me just bring that to the kind of top of our view a little bit. So this is the stuff that we're interested in right here for now, okay? And in fact, get rid of that one. So we've got app.maximize. That's just going to maximize the application window. Then it's going to do get workspace sum 13 is greater than 70 and then install that in that variable here. What does get workspace mean? Well, let me introduce you to a really cool resource. This is our, let me go to the top, Excel4 macro functions. This is almost like the Bible for Excel4 macro functions, pretty much the only one I've seen it exist, 650 odd pages long. Let me see what get.workspace is all about. Get.workspace, there we go. You feed it a number and it will tell you what the return value is going to be. So let me flip back to my code here. What was I looking at? We were looking at 13. So if we feed it 13, that is the status of the workbook root. That doesn't sound very right. Get.workspace. Workspace. Did I click on the wrong one? There we go. Feed it 13. Get the usable workspace width in points, so in pixels. So what is the width of the window? Also, 14 is the workspace usable height in points. So if the width is greater than 770, if the height is greater than 390, we're going to set ourselves, it's going to register in this variable here. Let's have a look at sum 42. If your computer is capable of playing sounds, another little sandbox evasion check. Get workspace sum 31. Let's have a look at 31 in here. If you're currently running a macro, it's in single step mode. So if you're single stepping through the actual macro code, it knows. And also sum 19 as well. Let's have a look at 19. If a mouse is present, return true. And then we see all of these variables here are then fed into this if block. So if any of those are false, if any of those are true, rather, then halt the code. It's not going to do anything. So they're the kind of anti-sandbox checks that this malware is undertaking. Is there a mouse? Is there a window? Is it of a particular size? Can the computer play sounds? All the kind of things that a sandbox probably won't be able to do, or certainly some of them won't. Then we get a few variables. We get this variable here, and you can see this, the YUEMV, whatever, is set to the value of whatever's in the cell E114. We'll get to that in just a second, but you can see that variable is then called as a function a couple of times. So it's basically going to pass execution to this line of code. So let's just, for now, because that's the first iteration or the first call to that function. We'll just worry about these bits here. So the next thing is we get a couple of variables set before there is a call to this function. So the first one is i632 to 679. Let's have a look and see what's in those. i632 is the start of that weird and wonderful encrypted code block all the way down to 679. There we go. So that's the range of that weird encoded content. Okay, and then this range here, D1650 to D1659. Let's have a look at that. D1650 is this bad boy here. So this list of integers. Now what we've got here is a list of ints, right? So we've got some weird content. We've got a list of integers, and we've got another little variable here, 251, and then a call to a function. In any other language, you would kind of smell this as, well, this function is no doubt going to decode that weird content, and it's probably going to use that list of integers as its key. So hopefully that's what we're going to see. So let's flip to E114. Where does that go? E114 goes up here to int, in fact, almost at the top of the code. So we can actually flip back on our text editor, go back up here. We have to just get rid of a bit of noise again. But this particular line of code, this line 1, is actually the start of this function, this decoding function. So where does it end? Well, it ends like any other function with a return statement down here. So everything in between that is the function now that we're interested in. Yes, there's some noise. Let's get rid of it. So let's get rid of that. Get rid of these noisy little noisy little things which aren't anything to do with Excel functions whatsoever. So a little bit tedious, but there's not that many of them in order for us to eyeball them super quickly and get rid. So let's just tidy all of those up. Bang, bang, bang. There we go. So now we're left with just 26 lines of this decoding routine. Now, I won't spend too much time going through this, but there is a super simple explanation for what this decoding routine is actually doing. But what we can also do, there's a couple of little tricks here. Before I dive into the technicalities of what it's doing and try and explain some modular arithmetic, which we'll get into because I love a bit of that, what I'm going to do is show you a couple of tricks that you can use in order to not even bother reverse engineering what all of this code does, but in order to see the output of this code rather than let it return from the actual function call itself. Because what's going to happen is, remember, we called the function here on line 54. There's a call to it. It's going to pass execution to this function, and then when it returns, it's just going to carry on. It's going to carry on executing whatever lines of code are beneath it. But rather than let it return and do that, what we're going to do is just change it to halt. Okay, so back in our code here, let's go back down to where that return line is, which is here. I'm going to change that return, and I'm going to change it to halt. So instead of returning, it's going to pause execution at that moment in time. So let me now run the macros, enable the content, and now it's got to the point where it's halted. So if I scroll down just a little bit, what you see is actually on line 251. Now, coincidentally, no coincidence, but coincidentally, line 251 was also one of these variables that was declared just before the call to our function. So 251, it's actually where the line is going to start writing the decoded content. So it's now started to put in the decoded content, the formulas of whatever that encoded blob of text was just before what we saw. And you can see now why it's pasted it in cell 251, because now the return call from that function is going to pass execution to the next line. And so this is the next block of code that's going to get executed. So what is all of this nonsense? Well, let's just quickly take this out of here. Let's put it into a text editor. Let's just view it, syntax, VB script, make it a bit more readable. Fortunately, there's no noise in this one, or certainly not much anyway, so we can kind of work out what's going on here. So the next bit, so just by simply changing that to at halt, we've got a nice little method of dumping out the decoded contents. So here, app.maximize +129 into cell 1833. What's 1833 all about in I1833? Let's have a little look. Jump down. All right. Okay. So this is this other what would be a key. Get my head out of the way. There you go. So you can see that this string of this range of integers, it's now going to overwrite them. So you might be mistaken. You might be thinking to yourself, okay, well there's 2 blocks of encoded content in here. We've just decoded one of them, or maybe this is the key to the other one. So let me just give you a little demonstration. So first off, what we can actually do, what I took the liberty of doing earlier, was that decoding routine with the halt. So I've just tidied it up a little bit and just renamed the variables to make it a little bit more readable. But we've got those 2 encrypted blobs of text that I've pulled out and plucked out just to kind of demonstrate to you, and that first key. So we've got some row, which is row 1, and in some column 6. So 1, 2, 3, 4, 5, 6. So in column F, hopefully we'll get the results. If I right click and run, hit go. I need to enable macros. Of course I do. What an idiot. So there we go. So if I right click, hit run, And again, we can see that actually each line of that encoded blob equates to that decoded content. And it uses this particular key. And I'll talk to you in a little bit about how it uses that key in just a second. So that's nice. But if we use the same key on that second block of text there, which is in H1 to H50 in this particular case. So let me run that. Let me just clear the contents here just to see, so we can see the output. Let me hit run and run again. We can see it starts to run. It starts to decode the text, but actually it doesn't decode it. We just get a load of gibberish nonsense. And then we start to get a load of errors as well. We don't want that. That's obviously not good. So it's obviously not using that key. So you might be mistaken and you think to yourself, okay, well, I've got another key here. So maybe it's this key that it's using. Well, that would be great, wouldn't it? So let me just paste that in there and let me change that. Get rid of these. Oops. Get rid of these values here. Right, so if we change the key to C1 to C6, hopefully we'll see something else. Clear the contents. We'll run it again. Bang, or we get errors again. And the reason why we get errors is because it's not a key. And so if we go back to our code here, it's actually changing. It's overwriting the values that are in I1833, I1834, I1835. It's overwriting them. So if these particular conditions exist, so let's have a look. Get Windows 7. What does 7 equate to? Let me have a little look. If the formula bar is displayed, again, might not be present in a sandbox. What's the next one? 31. I think we've already checked for 31, but it's obviously checking again. So if it's in single step mode, and then workspace 14, which was the height, I think. So if that's less than 390, it's going to add 103 to 1834. So it's going to overwrite that with plus 103. Get window 20. What's get window 20? Let's have a look in our little Bible. If a group is present in the workspace, okay. What's 19? Let's have a look at 19. If a mouse is present again. Okay, so it's doing those basic checks again, and it's going to write the values 112 into 1835, for example. Then it's going to wait for 2 seconds, and then it's going to do now. Get the value of now. Then it's going to wait now plus 2 seconds, get the value of now again, subtract the two values, and put that into 1836. So what we'll be able to see, hopefully in just a second, is the second key being dumped out. Then it's going to write a DAT file, which is a weird and wonderful file that we saw. But look at this, fwrite into E260, the chart random characters between 33 and 125, and then turn them into their ASCII representation, and then it's going to write them into that DAT file. So that DAT file is just a load of nonsense, just there to throw us off. Then it's going to, we can see here's a call to shell 32, shell execute. It's going to export the contents of that Excel security registry location. And the reason why it's doing that, it's looking to see whether or not there is that risky setting for where macros are already enabled and no one needs to click on it. And if you have that risky setting enabled in your environment, you definitely shouldn't do. But that will set this particular flag in the registry. And so again, something a sandbox will do. Sandbox isn't going to enable macros and click the button. It's just going to auto fire the macros. And so if it can detect that presence of that registry key, then it again thinks it's in a sandbox and will close out. And it's a second method it uses to do exactly the same thing, where it writes a text file, a VB script file, and executes that VB script file as well to do exactly the same thing, and then deletes itself and tidies up. And you can see here's the search for the number 1, which will be the return value in that registry key, and then the value of 119 going to 1838, which is the latter stage of our key here. So what we want to do, again, let's go back here. So we've now got all of this. Scroll up. Come on. Where are you? Keep going. So in column E, we should now have all of this decoded content that we ran earlier with that halt routine. So that's great. And the next thing that happens is after it's run that, so here is, in this blank bit here, is going to be all of our newly decoded content. The next bit, it resets some variables. So it now sets the encoded content to be that second block. It now sets the key to be what it's just overwritten in those texts, in those cell ranges that we saw before, and then calls the decoding function again. And once it's called a decoding function again, it's going to halt. So that's great. So let's just do a quick demo. So before it runs that, let me just put a halt in here just to pause it. And if I scroll to the top onto this one, right click and run. If I run that now, it's going to wait to a couple of seconds. It's going to enumerate the registry, do all that nonsense. That's fine. Let me scroll down a little bit again. So what was it? I1833 or something like that. Keep going, nearly there. Come on. Well, if I get to 1833 now, come on, where are you? We can see here it's overwritten with these particular values. If I go back into this, paste the key in here. If I now run it, run that again. Now the second block decodes itself using this particular key. So it's almost like the key is polymorphic. And here we can see the next stage of code. So we can see the care.academy stuff that we saw before. It's going to write to this HTML file using the API call URL download to file. But we can see some more network indicators now. We can see another C2, another C2, and yet another C2. And then we can see as well there's like a backup method where it writes a VB script with exactly the same kind of capability to enumerate those C2 locations and write the response body to a file. And then we can see down here the alert that we saw is actually maliciously generated by the bad guys, and we can see as well that it's going to try and execute the content using run DLL32. It's going to wait a second, then it's going to tidy itself up, and then it's going to close. So therein lies a super simple method, just using halt instead of return and executing halt just to get the extract the key in order to decode this particular sample, and so you can extract all of the indicators that you need. Now finally, let me just go back and just explain to you how it was actually how this decoding routine is actually working. It's a little bit noisy to understand it in here. However, just bear with me. So it sets a load of variables. The first one to be is 0 at the top. And that just kind of sets some counters up and running before it enters this while loop. And this while loop, we've got a nested while loop within it, but don't you worry about that, is basically iterating over the length of each cell in the encoded content. So we go to the encoded content, it's going to grab the first cell in this range, and it's going to grab the first cell, and it's going to iterate through every character in that cell. And the first thing it's going to do is this line here on 16, this one here, it's going to convert it from its ASCII representation, it's going to convert it into a char code. Once it's got it into a char code, it's then going to iterate through the key index. So it'll take each index in the key, which is already in its char code value, if you like, in its decimal value, and it's going to grab each index, and then it's going to subtract the two from each other. So super simply, and I've written a little bit of an example here in Go just to kind of easily explain it. So let's say, for example, this is like some of our encrypted content here that's already converted into its char code. Here is one of the keys, the first key that we saw, and all it's going to do is loop over the length of the text, and then it's going to subtract the key at the particular index that we're at within the loop. So in round 1, I is 0. We're going to take 0 value here of text, 0 value of key, first value, second value, etc. But what happens when you get to this value here, this 178, which is like the whatever it is, 10th, 11th, whatever index? Well, there isn't enough integers in the key, and we want the key to repeat. And so what we actually use is the modulo operator, which is what the bad guys have done as well, is that so you take the modulo of the length of the key. So if you get to like, what is this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this will be index 10 because it's base 0. So you get to like index 10 of our ciphertext. Well, you need to do 10 modulo. Is this 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I beg your pardon. It's 10. It's base 0. So you've got index 10, and you need to do 10 modulo 10, and that's 0. So you're going to go back to index 0, which is 100. Then you've got like 11 modulo 10, which is 1, 12 modulo 10, 13 modulo 10, etc. And so you're taking the difference each time and wrapping around the index of the key. So it's almost as if the key is repeating. Where have I gone? So the key would be repeating 129, 102, 103, etc. So nice and easy. So that's all it's doing. Super simple. And hopefully you've seen, just by using a couple of simple techniques, rather than returning from the function call itself, you can halt. And that will give you all you need to dump out the C2s, to analyze, get closer to the bad guys, and work out, you know, all of the other fun stuff that this might be hiding. Hopefully that's useful to you. Hopefully when you're seeing these samples in the wild yourself, you're going to know and feel a little bit more comfortable dealing with them. If you like the video, please give it a big thumbs up. If you really want to find out some more about my channel and see some more of this kind of content, then please subscribe, and then also join me on Twitter as well, @CyberCDH. I'd really welcome your questions and comments. Thanks very much, everyone.